Okay, sounds good. Cool. Well, then, yeah, I'll get started. So my name's Bill Clark. I also go by Lieutenant Randolph. Randolph is my middle name, so that's my gamer tag. And this is my second talk with Code Labs. And today I'm going to be talking about visual effects in games. If you want to see the previous talk about game engine architecture, it's up on the YouTube channel for Code Labs. But yeah, so let's start off by talking a little bit about who am I and why am I here talking to you about visual effects. So I've been a professional game developer for 12 years. Over the course of that time, I've done a variety of different things, mostly around programming. I've done graphics programming, tools programming, quite a bit of gameplay, so like generalist stuff, so scripting, animation, like connecting a bunch of the systems together. And then over the course of those 12 years, I've also done occasional design work, but I've been like leaning much more heavily into that in recent times, as I'll talk about in a moment. And I've also spent 2.5 years of my career as a manager, so managing a team of other programmers and helping support them in their careers. So I've been all over the place. And then this year, starting in January, I became a solo independent game developer. And that's been a very interesting learning experience after spending a lot of time in the industry and learning from a lot of like really great companies and really smart people at those companies to now be out on my own with much less support. Like I have social support around me, but I don't have like technical or creative support particularly. And so that's been a really interesting journey to learn how to be self-sufficient on those things. But yeah, so I started my career at 343 Industries, which is a subsidiary of Microsoft. And there I got to work on Halo 4, which was the first Halo game made by that studio. The previous Halo games have been made by Bungie. And so we inherited their engine and a lot of the content. And so I was the visual effects programmer for Halo 4. And I feel like I got to have this almost like apprenticeship where I got to learn from all the code and all the content that Bungie had created. And they're really like amazing at visual effects. And so I got to learn a ton about how to do really cool visual effects. And that's where a lot of the stuff that I'm going to talk about today, the knowledge comes from there. And so you can see in these GIFs here, one of the things that I spent a lot of time working on that project was this effect where we could dissolve out or in models into like little glowy particle bits. And we use that in a lot of different shots in that game. After that, I went over and worked at Valve Software on Dota 2, and I was there for almost a year. And most of the time that I was there, I worked on a system called the custom game mode system that allows players to create their own custom game modes that are different than the standard 5v5 map. And the first custom game mode that we released as a demo of the feature was the Wraith Knight event. It was a Christmas event where players would cooperatively try and defend their base against waves of enemies. And I'm particularly proud of the work that I did on that on a number of the boss fights, including the final boss fight against the Wraith King that's pictured here. So that was where I got like a lot of good practice on how to be a designer. Then after working at Valve, I went over to Riot Games down in Santa Monica, and I worked there for 5.5 years on League of Legends. As I said, I worked on a mix of gameplay tools and graphics, and that was also where I became a manager. And so the capstone of my time there was when I was the engineering manager for the Champions team on League of Legends. So we were a group of like 4 to 6 engineers, programmers that would support a team of about 60 to 70 other people, designers, artists, production, narrative, and we would help make all the technology that was required for Champions to be released. And so you can see here 4 of the champions that I worked directly on as a programmer. So I worked on Rakan of Zion Rakan. I worked on Aatrox, Yuumi, and Set. And then I also supported other champions as a leader on the team, but these are the ones that I actually wrote code for. Lost my things. Cool. And so then after leaving Riot in December, I started working on what I call Lieutenant Randolph Games. And I've been doing a whole bunch of different stuff over the course of that time. For the first several months of the year, I was working on a game called Kinematic that you can see here, the main character Gem swinging back and forth. It It's a very ambitious game. It's a Metroidvania platformer with some factory elements. Ultimately, I realized it was too big for where I'm at in my career. I think it was kind of cocky for me to think that I would finish that project because it's huge. When I took a step back from that, I've started to work on smaller projects. And last week, I released Craft Defense. That's a tower defense game on the Pico 8 hardware, or software, which is a virtual console. It's a pretend console as if it had existed, kind of in the era of like a Commodore 64 or Atari. But it never actually exists as a piece of software or as a piece of hardware. It just exists as a software like an emulator. And yeah, I've been really happy with the response to Craft Defense. I'm going to keep working on other games on Pico 8. And the other thing you can see here is I also have a video series called Game Design Principles. And I started that because I noticed that I love the genre tower defense, hence making a tower defense game. And there really aren't a ton of resources talking about the design of that genre. And so I started making a series talking about the design of tower defenses. And I'm hoping to do some more videos about some other genres that are interesting to me in the coming months. So all of this is to say I've been doing a lot of different things and like trying on a lot of different hats and seeing what works for me. So that's me. So what am I going to be talking about today? I'm going to start off by giving a definition of visual effects in the context of games. And it's interesting because visual effects in the world might mean something very differently, because a lot of people, when they hear the term, they think of visual effects in movies. And in movies, that term typically means anything made by a computer. And so if you work on video games, everything is made by the computer. And so visual effects has a more like narrow meaning for video games. So I'll talk about that. And then I'm going to do an overview of a bunch of common visual effects systems that are used in games, specifically particle systems, trails, and screen effects. And there are other types of visual effects, but these are the ones that you use the vast majority of the time. And so this will cover most of what happens in visual effects in games. And then as I'm talking about those, I'm going to be hooking them into a hierarchy of visual elements that is going to help you sort of think about how those systems relate to each other and potentially like get some ideas of how they might work together. So what is visual effects in games? We can start off by talking about art in games. And so the idea of making art for games is that you've got a bunch of red, green, blue pixels on a screen that you need to fill. And in the case of the Pico 8 that I've been working on, it's 128 pixels on a side, so it's a few thousand pixels. But for most monitors, it's several million pixels that you need to put together every frame, 30 times or 60 times a second. And then those RGB pixels are going to typically be 8 bits rather per color. So red has 256 possible values, green 256, etc. There are newer technologies like HDR that allow for more bit depth that I haven't dug into, so I can't speak to them with authority. But in general, you can just think of trying to come up with an 8-bit value for red, green, and blue, and that's mostly what happens in games. And so then the art that is producing those pixels can take a lot of different forms. So in this image of Set slamming this target dummy into the ground, you can see there's environment like these mountains and brush and river here. There can be characters like Set and the target dummy. There can be UI, like there's some text of how much damage the dummy has taken, as well as these health bars and stuff. And then there's this thing called effects. And on this image, there's lightning, there's this slam when he hits the ground, maybe there's the glow on his shoulders, but basically like everything that isn't environment characters or UI is probably something we would call effects, but still, like, what does it mean? Tongue in cheek, I can say that it's things that are made by the effects artist. I'm being a little sarcastic there, but honestly, like from my career and my experience there, like this is actually the clearest definition that I have in my head. Is I've worked with character modelers and animators and environment artists and concept artists and UI artists, and then there's an effects artist that is doing other stuff, and that's what I think of as effects. And so like preparing this talk, I had to think a lot about like, what does it mean? Like, what do they actually do? And the best thing that I could come up with as a differentiator is that visual effects are art that has a significant amount of randomness in it. So if I think about a character playing back some animations, there doesn't tend to be a lot of randomness. There may be a little bit, but in general, it's very carefully scripted and authored by the animator. Whereas, and it's not to say that like visual effects aren't carefully authored and put together, but they're still like every time you play them back, they will typically look different because they have a significant random component. And so, like some of the other axes I consider to try to define it, you can't really define it based upon where it occurs in the game because you can put visual effects on an environment like a waterfall or on characters like the glowing shoulder blades for Set. They can be in UI. They can be just floating loosely in space. Visual effects can be permanent things that stick around for the entire playtime, or they can be temporary, like flashes, like explosions. They may be small or large, obvious or subtle, have a realistic look or an iconic stylized look. They might be very noisy. They might be very crisp and clean. So like there isn't a lot of other ways I can think of to define it other than the presence of randomness. But the other thing I would say about it is that the visual effects artists tend to be very technological minded relative to other artists. Because in order to get effects to look good, you have to do a lot of complicated math and you have to work in a lot of different tools, including some tools typically that are custom for the engine that you're working in. And so like a character artist can spend all their time in Maya and master this one tool and become very good at that. Whereas a visual effects artist doesn't have one place that they must be good at. They have to be good at a lot of different technologies. And so as an art form, it tends to have a lot of math and a lot of technology involved in it relative to other art. So the rest of this talk, I decided to do an experiment because I'm kind of obsessed with this Pico 8 thing. And so I have a bunch of visuals here that I'm going to present using Pico 8. So this is actually a running quote game. And I'm going to be posting it on itch.io and sharing the link with CodeDay. So if people want to like look at the source code for everything that I did here, you'll be able to. But yeah, so now I'm going to jump into this and start showing off some stuff about effects. So the first thing that we're going to talk about is particles. But as I said, you know, we're trying to fill up the screen with thousands or millions of red, green, blue pixels. And so one of the things that we can do is just put a bunch of points in space and give them a color and then draw them as pixels. And so here in the visual hierarchy, we've got our screen that we're trying to fill, and then we can put some RGB pixels up on there. And relative to other game objects like characters or the environment or you know, a flag that might be captured or a gun or whatever, one of the key things about particles is that you try to have them be extremely lightweight. You want them to take up very little memory and take up very little processing power so that you can have thousands or millions of them on screen at the same time. So so we can have pick particles just as points in space, but they become a lot more interesting as soon as we have them move. So like you can see, like just looking back and forth between these two images, like this image is very boring. It's already a lot more interesting once they start moving. So yeah, so then in our visual hierarchy, like in order to create some pixels, we might create particles. Then those particles can be stretched out to have width and height so that they start to take up more space and start to feel like objects in the world as opposed to maybe stars or just points in space or confetti. We can, you know, rotate them and have them, you know, have their shapes be adjusted. And then like the first really like the first thing that brings a lot of life into them is once you give them acceleration, and in particular gravity is something that our brains really understand. And so once you see this image here, this very much looks like, I don't know, confetti or fireworks or something that the brain understands how that works because we're used to seeing things fall due to gravity. Let's see. Oh, and one other thing to talk about on the visual hierarchy is that we've got these particles that are, you know, drawing, and as soon as they're not just drawing individual pixels, we need to have triangles, because in order to draw these squares, we always draw them out of two triangles, and so they are made up of three vertices, and the computer understands very well how to take three vertices, turn them into a triangle, and how to then chop that triangle up via a process called rasterization into all of the pixels that it's going to affect. So back into the demos here. So it, instead of just having the acceleration be sort of boring in one direction, you can start to have the acceleration be doing interesting things like caring about where the particle is. So in order to do this swirl here, we need to apply an acceleration that has something to do with the position of the particle relative to the point that it's swirling around in order to provide a centripetal force in order to have it rotate. And then we can do even more interesting things by having the position that that force is applied relative to be something that is moving around. So here I can move the mouse around and all the particles are trying to accelerate towards the mouse. And so this is like, you don't generally put effects following the mouse very often. Maybe you would for certain purposes, but it might be very common for that to be something where a character has visual effects that are following them around. And so the character in the visual hierarchy over here is something that can affect where the effects are going. And then another thing that you can do with particles is have them collide with things, and that again helps like ground them in the world, and you can have a world that they're colliding with. This is something that can be very expensive, and so it's important that you have a relatively low resolution version of anything that particles are going to collide with in order to make it cheap to collide thousands of objects against that world. And so typically when you make a game world, you're going to have a high resolution version of it with a ton of triangles that is going to be the thing that you draw. And then you're going to have a much lower resolution version of it that's the collision mesh that things can bounce against. And so here on this demo, the collision mesh is extremely simple. It's simply top, bottom, left, and right of the window, that if the X or Y exceeds those bounds, I just bounce it back in the other direction and shrink the velocity a little bit. But obviously you can think about if there's a complex game world with mountains and fields and buildings and whatever, then that's going to be a much more complicated collision that you're going to have to do. So then let's talk a little bit about shapes. So one of the things that is important to make your visual effects look good is that you can't just be drawing these boxes, because those don't look like, I mean, like there's a certain game where that works, but if you're trying to make Halo, if you're trying to make a game that looks realistic in any fashion, you're going to need something else. And so we're going to need the ability to interpolate values across a triangle. So here you can see that there's a red, green, and blue value that are being interpolated. And because Pico 8 doesn't give me a ton of colors, I didn't blend across the entire triangle, but you can imagine that there's sort of like a gray here in the middle. But if we have this idea of mathematically interpolating values across the triangle, then we can interpolate a coordinate on the particle square that goes from 0, 0 down in one corner up to 1, 1 up in the other corner. And so then we can know exactly where any given pixel of that quad is located within the square, and that is then going to allow us to draw a texture on it. And so that texture can be a really simple looking smiley face like this, or it could be something more complicated like a spark, or a puff of smoke, or a drop of blood, or any number of more interesting things can be drawn by mapping it across the quad using interpolation of UV coordinates or texture coordinates. So that is another of the pieces of the visual hierarchy that we can add, sort of like we can have triangles, we can have textures, and you put those things together and you can draw them to get interesting pixels. So then the next thing that is worth mentioning is, like, you usually think about particles when you're working on a game as quads, and you usually think about those as quads that are, there's a technique called billboarding, where you make it so that as the camera rotates, that quad is always facing towards the camera. And so if you ever play a game where as you rotate around something, you see that it feels like it's spinning, that's because it is billboarding, which is a way that you can just draw a single square and have it always like look good from stationary camera angles, even if it has artifacts when you rotate the camera. But instead, we can take each particle as a point in space with size and rotation and color and whatever. We can then draw a full model there. And this is something that, in particular, Riot Games uses a lot. It's sort of like a style thing of like different effects artists have different approaches, and Riot specifically, they focus a lot on using models for a lot of visual effects. And so some of the ways that they would use that is for like having a shockwave that actually like comes up above the ground and has like 3D height to it. Or they would have like, as a character is moving quickly using the ghost spell, they might have like versions of that character sort of ghostly drifting off to give the illusion that the character is moving very quickly. But so anyways, on the visual hierarchy, a model is something that typically you think of as being used by a character, but it can be used by a visual effect as well. And so then the model is going to have a lot of triangles. It's going to have a texture. It's going to have bones that allow it to be animated. But it's just sort of like another level of complexity that can be used as we move towards trying to generate those pixels for the screen. So the next thing I'm going to talk about is we've spent some time now talking about particles, which are sort of like the end result, the last thing that we're going to produce on the way to drawing pixels. But then a step further back from that is the concept of an emitter. And a little bit of terminology here. I use the term emitter. I definitely prefer that, but another term is particle system. And they're not precisely the same thing. There are some engines that have particle system as a parent that contains one or more emitters. There are some engines that only have particle systems or emitters as a concept. So they're like very close to synonymous, but like people might nitpick you if you try and say they're synonymous, but I'm going to say they're synonymous. But basically an emitter is something that is going to produce particles. And so we've seen some examples already of things where they might produce particles in a sudden burst, like an explosion. We can also have emitters that are emitting particles over time. And one of the interesting things to think about on this front is that you can have emitters that emit particles very slowly. So if you think about like a Tesla coil or a Van de Graaff generator in a video game that's producing sparks and electric arcs, you might have those come up every couple of seconds. You'll do a bzzz, and then this particle appears. And so like they don't need to be producing a ton of particles. They can be producing particles rarely, but it's still something that emits particles is going to be called an emitter. And so let me reveal that on the visual hierarchy over here. But so the emitters are responsible for like where are the particles going to be, as well as like in this A shape, or they may be emitting off of the vertices of the model. So if you remember from my images from working on Halo 4, we emitted particles from the vertices of the character as the character was dissolving. The emitter is also responsible for the velocity and pretty much anything else that is sort of like the initial parameters of the particle. The emitter is going to be setting those for the particle. And so we've got emitters that can be sort of like creating a bunch of particles and setting up their initial parameters and sending them off to be simulated. Then there's the concept of effects, which is one level above emitters or particle systems. And the idea of an effect is that you can group multiple particle systems or multiple emitters together into one cohesive unit that the game can then refer to. And so here you can see, like, I don't know how they're giving out the Oscar for technical achievement this year, but they can just mail it to me for this beautiful fire. The interesting thing here is it really doesn't take very much for your brain to get what's going on here. Just some simple colors and some motion, and you can tell like this is fire with smoke. And I'm tongue in cheek about how bad this looks. It's really janky, but like this is actually part of the process oftentimes of making a visual effect, is that an effects artist will do what's called blocking in, where they just try and get the motion and the shapes and the colors right before they spend any time like polishing and making it look pretty. Just because if you squint at it and it looks kind of the way you want it to, then now it's worth taking the time to polish. So we can put effects up here as at the visual hierarchy, that they're sort of at the level of the world and the character. And they're at that level in a lot of ways, not just sort of artistically, that they're sort of complicated, but also the way that the game interacts with particles isn't that a designer says, I would like 10,000 particles, please. The designer says, okay, this character does this ability, and I want the explosion effect to play at this moment. And an environment artist is setting up the waterfall, and they're like, I want the waterfall splash effect to be here. And so effect is the noun that the game interacts with and that the other developers on the team interact with. And then the effects artist is the person who is then making up that effect out of multiple emitters and other pieces. And the other thing that's worth pointing out about effects is that they oftentimes will have things in them besides visual effects. So this object of an effect for the game is going to have things like sounds, may even be spawning like gameplay objects. So working on Halo, one of the things that was interesting about effects in that game is that like when you blew up a tank, the chunks of the tank that fell off would be spawned by the effect, and you could like jump on them or hide behind them for cover. And so like the effect is not just a visual thing, it's also something that might have gameplay implications. Whereas most of the other stuff, the art here, doesn't directly affect the rules of the game, it just affects the presentation of the game. Let's see. Oh yeah, so I mentioned that here, sounds and game objects and stuff. So another thing that I want to talk about that is very useful, that isn't part of the visual hierarchy, but it is a very important tool for making effects, is curves. So the idea behind curves is you take the idea of a mathematical curve that is on two axes. So you have an x-axis that is some input into the curve, and a y-axis that is some output from the curve. And by setting up this 2D space for the curve to operate in, it can be very powerful. And so typically what you'll do is you'll define a curve that has a range where the x can go from 0 to 1, and then the domain. And then the range is arbitrary, whatever, like it might even be a color. And so you can have red down here at the bottom and white up here at the top or whatever. But basically you input some parameter of the game or the particle or the effect into the x coordinate of a curve in order to find out some value about that effect or that particle system. So one of the common uses of this that's pretty simple to think about is you can have a smoke puff that appears, and as it goes up, it will get larger and it will get more transparent. And so the input to that curve would be the particle's lifespan. And so it's going to go from 0 to 1 as the particle goes from just being born to disappearing. And as the input goes from 0 to 1, as its life goes from 0 to 1, the transparency is going to go from pretty opaque to fully transparent, and the size is going to go from small to large. But if you have a good curve system, you can put curves on like every parameter of a visual effect. And so this is something that in particular Bungie uses to great effect, because like every parameter that you can set on a particle system, on an emitter, is a curve. And so you can punch in, it's just a constant value that we spawn 5 particles per second, and they're always 1 unit in size. But instead you can, for any of those things, change it into a curve. And as I mentioned, you can have it be colors too. And so you can have it be, choose one of these 5 random colors, and over the course of the particle's lifespan, move across to these other 5 random colors, but stay on the same line, or start at these 5 and go to a different random color over the other side. So it's extraordinarily powerful if you have this framework of curves that allows you to set the values of your effects. So I didn't build anything that complicated for my simulation here, but still, just to give you a sense of like what curves look like, here I have a little demo where the particles are moving and stopping and changing colors. And so basically it's sort of like a red light, green light type of thing, where when they're moving, they're yellow, and when they're stopped, they're red. And so this is a sine wave that is controlling whether they're moving or stopped. And we're inputting into that sine wave an emitter time. So it is time since the emitter was created. However, if instead of inputting the emitter time, we input particle time, we then get a very different look, because now we're spawning particles at different times, since they're all on different time scales in terms of where they are on that curve. And so they're going to be moving and stopping. And I'm not sure if you have enough resolution on the stream to be able to tell, because you have to squint and tell that they are actually moving and stopping individually. But so you can get very different looks by choosing what the input to your curve is here. And so, it's not that one of these is better or worse, they're just conveying very different things. This is a very uniform, like some organization is controlling what these particles are doing, versus this is a very chaotic mess of like separate actors acting. And that your brain will put a lot of like will read a lot of intent into what is actually just like random motion here. So it's very interesting to observe. So another technique that is useful for making good visual effects is blending. And in order to understand blending, we have to introduce another element to the visual hierarchy. So I've been a little bit glib as I've been talking about visual effects drawing and particles drawing on the screen by saying that they're producing pixels. And that's not quite right. There's a technical term called a fragment. And so a fragment is something that is on its way to becoming a pixel. So I mentioned that we've got triangles, and we slice those triangles up into individual squares for every pixel of the screen that they cover through a process called rasterization. And after we're done rasterizing, we have a bunch of fragments. And so these fragments, I like to think of them as coming in and landing on the pixels of the screen. And when they land on the pixels of the screen, there are different things that we can do with the red, green, blue, and alpha values of those fragments before they hit the pixel. So one of the things we've already seen that we can do is just write out onto, like, just stomp on the color there and be fully opaque and just replace the color with whatever we have. And so here in this little demo, you can see that the newest particle is always going to draw on top of everything else. And so it doesn't matter what color it was before, whichever is the newest particle that hits any given pixel, that's the one that we see. And so that's the simplest thing that you can do with a fragment, is just have it write directly to the pixel. Alternatively, you can do what's called alpha blending, or it's a linear interpolation. Pardon. And the basic idea here is that we've got a red, green, blue, and an alpha value that are coming in from the fragment. And the alpha value is how opaque that fragment should be. If it's 0, that fragment should not actually change the color of the pixel. And if it's 1, it should replace the color of the pixel. And anything in between, we want to sort of blend between the color that's already there and the color that's coming in. And so then we do alpha times the incoming color plus 1 minus alpha times the existing color, and that's an alpha blend. And then the other type of blending that's most commonly used is, instead of replacing the color that is underneath it, we can instead add into the color that's underneath it. And so then the red, green, and blue values will all become higher, and it will drive the pixels to look brighter. It will drive them towards white. And so this is particularly useful for things like fire or sparks or electricity, because if you overlay sort of the dim part of one particle of fire over the bright part of a different particle of fire, you don't want to dim the fire. You want it to become even brighter still. And so this technique is used. And there's one other type of blending that, sorry, two other types. Another type that I didn't show here is called multiplicative blending. This is particularly used for like smoke. If you've got sort of like a greenish, like poisonous smoke, if you multiply the color behind it by that green color, then it will turn everything like a little bit more sickly looking. And so that's a technique that can be used to sort of like shift colors underneath something. But the other one it's kind of complicated, but I just want to mention it just in passing, is like there's a technique called pre-multiplied alpha. And it's mathematically kind of complicated. I still only partially understand it, even though I've used it like in my games. But it basically allows you to do alpha blending or additive blending, or kind of like a mix between them, just by doing slightly different tuning of your parameters. So it's actually like pre-multiplied alpha is really the technique that you want to use sort of under the hood in an engine, in like a modern engine. But conceptually, thinking about it as alpha blend and as additive as two separate things is I think a lot easier to consider. So I like to think about them that way, but then I remind myself, oh yeah, but pre-multiplied alpha is the thing that we're really using. So yeah, another technique that we can use This is one that Bungie really uses a lot, and I wish that more games used it because it's really clever and you can do some really cool stuff with it. But the idea here is if somebody draws a really nice high resolution texture, I didn't draw this. There's this tool online called Effect Texture Maker that you can produce images like this. But if somebody makes a really high quality texture like this, that has like a significant cost to it. It takes a long time for an artist to make a good looking high detail texture. It's also going to be expensive in terms of the memory on disk and when the game is loaded. And so it can be nice to try to get as much use out of that high quality texture as you possibly can. And so you can see in the bottom left corner of the screen, I've got a little palette. And here it's just a grayscale to show you this is what the texture looks like. It's going from black to white in this sort of like smoky shape. But then you can change out the palette, but still keep the texture as a lookup. So the texture has values that go from 0 to 1 in just one channel. So it's not a red, green, blue texture, it's just a red texture. And so you get a value from 0 to 1, and then you use that as a coordinate into your little palette here. And so it goes from 0 at the left side over to 1 at the right side. So we can then swap out our palette, use the same detail texture, and we can get, a fireball. And then we can swap it out again and get sort of more of a dirty smoke cloud. I made it a little bit darker, a little bit browner. If it was a higher resolution texture, I can more convincingly do this. You can make it look like a bush. You can have it look like some sort of weird mutant cotton candy. But one of the really cool things that you can do with it, and this is something that I've kept an eye out. I really haven't seen anybody except for Bungie do this. Is you can animate your palette over time, and then the details of your smoke that your artist created become not just like details that show up in one place on the screen, but they become temporal details. They become details about how the effect changes over time. And so with a relatively sort of bubbly smoke, like the relatively normal looking smoke texture like this, if you just slide a sort of glowing blue through the palette, then you get this sort of like electrical ring spark plasma thing going on. And so if you ever go and look at a Halo game and you look at the Covenant weapons that are all glowing greens and blues, you'll see this technique all the time, because they use it all the time to get these really nice like moving arcs that have a very organic feel to them. And one of the other things that, like with this technique, they do this thing where you have multiple black and white textures sort of scrolling past each other, and then sample the distance between the particle and the ground behind it in order to make these like electrical forks that will follow along the ground, so that there's this like hover bike called a ghost that has these electrical tendrils that are like seeking out the ground. And it's just clever use of this technique of like modifying the palette of a grayscale texture. So there's a ton of stuff you can do here. If there's one thing that I wish more effects artists were using, it'd be this, because it is a very powerful technique. So now I'm going to switch gears from talking about particles so much to a different but pretty related concept called trails, which is the last piece of our visual hierarchy here. That's sort of a sibling to particle systems and particles. So the idea behind a trail is that you attach a trail to an object, and then as that object moves through space, it plops down little things that we call profiles at the points that it traveled through. And it can leave those profiles behind based upon an amount of time having passed or an amount of distance being traveled. But then those profiles can have parameters just like particles, and they can have curves just like particles. And in fact, in some engines, they actually are particles under the hood. And so a trail is just a particle system that when you go to draw it, you connect them all and just draw like quads, triangles that connect through each of the particles. But yeah, so if we're looking at this as a way of visualizing a trail, one of the things that's important for the artist to tune is that there's not a right value for how frequently you should be dropping profiles. And so I could certainly lower the frequency that we drop profiles here and we can see that the shape just gets completely lost. And so there's definitely like too low of how frequently you're dropping profiles. But I can also turn the number way up, and you can see the profile count. This is all added processing, it's added memory, it's added draw time. And if I kept pushing the right arrow, then I would eventually crash my game because I'd run out of memory. So this is one of the interesting things, is that your effects artist needs to think about like the way that the effect or the way that the object that the effect is attached to is going to move in order to figure out how many profiles to do. And actually, working on League of Legends, working on Rakan, I spent a bunch of time working on the trail system because Rakan's ultimate ability, he would run really fast and try and run through enemies to charm them. But one of the interesting things in League of Legends is players click with their mouse all over the place. And so the characters are constantly spinning and twisting and moving in lots of different directions. And so the trails looked like garbage when we tried to have a trail that followed this character. We'd only ever use them for like missiles that move predictably through space. So this character zigzagging all over the place looked like garbage. And so I had to put in some new technology for the trail so that as the trail curved, the profiles would shrink so that they wouldn't overlap with each other based upon the curvature of the curve. And so if the curve was like a complete like 180 instantaneously, then they would shrink down to a size of 0, and then they would expand back up as the trail went straight. So it was a neat problem to work on, to try to solve this sort of like, how do we allocate our profiles and make them draw correctly in order to look good. So then the last type of effect that we're going to talk about, we've already talked about pixels in the screen in our visual hierarchy, but we can actually just directly manipulate those rather than manipulating some object in world space. So the idea here is we've drawn a bunch of stuff. We've drawn environment and characters and visual effects, and they're all sitting there in some buffer of red, green, and blue values that are almost ready to go up on the screen. But then most game engines at this point will do one last step called post-processing, where they take that back buffer and they do some math to it that is tuned by artists or programmers or whatever in order to make it look better. And so some of the things that can be done there are things like, what's the term? Depth of field, where you can simulate the way that cameras have a particular depth that is in focus. And so you can blur things in front and behind in order to draw the player's attention to the things that are in focus. Or you can do things like exposure, where when the character comes out of a cave, you can make the world seem extra bright to simulate that the eyes haven't like fully contracted yet to offset how bright things are. So there's things like that. But basically, you're just like, anytime you do a bunch of math where you want to look at the pixels and change them before they hit the screen, that's what a screen effect is. And as I point out here, since you're dealing with potentially tens or even hundreds of millions of pixels, you need to be very careful about how expensive the screen effect is, and in particular, memory access. So how many other pixels you look at before deciding what color this pixel should be is going to be a really significant factor in how expensive these are. So it's definitely one of the places that people really spend a lot of time tuning and very carefully doing exactly as little as possible to get the effect that they want. So here I have a very simple screen effect of just stippling out the screen into different colors. But a more useful one that is less sort of simple and toy-ish like this is the technique of bloom. And so this is most games at this point have a bloom pass. And the idea here is if you look at the letters of this extra hot text here, they're just white the entire time. And that's as bright as my screen goes. Like, I can't make them brighter. But if I want to make them seem brighter, then I can blur out to make it seem like, oh, actually, no, these are glowing really hot. And so we get this sort of orangish blur out. And that's to simulate, I believe it's a retinal artifact that like when your retina is hit by extremely bright light, that it will then sort of like stimulate the nearby parts of the retina. I'm not sure, but that's my mental model of it at least. But as you can see, like it definitely conveys the idea that this is even brighter than white because of the fact that it's bleeding out. And if the color here that was being blended out towards was more of a blue, then you'd have a different sense about like what exactly is going on here. You might think, oh, it's electric text, or it's neon text or something. But yeah, so bloom is pretty common, and the way that it tends to be done for performance sake is to take your screen buffer and shrink it down. First in the X direction and then in the Y direction by like grabbing several pixels together and jamming them into one pixel. And so you do it in one direction and then the other direction, and then you sort of like draw that result back across the screen. And if you do the math right, you can get what's called a Gaussian blur. You can have the math of a Gauss curve that is preserved by doing it in this way that is a lot cheaper than having each pixel go and ask like, hey, what are my 32 nearest neighbors doing as far as brightness? You can have it instead be sort of like collapse it together and then spread that information out. So there's a lot of neat sort of like techniques that people have come up with on how to do screen effects for cheap. I think there we go. Cool. So that's the end of that demo, and actually pretty much the end of my talk. So yeah, do people have any questions? And yeah, I guess type them in the chat in particular. Okay, yeah, Vervin asks, what are these demos written in? So this is a program called Pico 8. It is a virtual console that is a pretend console that it's only exists as an emulator. And then it is Lua code. And so, so as I will be releasing this as a standalone cart that you can go look at. I'll also post with the GitHub that it lives on. So you can go look at all the code that I used here. And it'll be able to be run on itch.io on the website. If you own Pico 8, which is $15, but it gives you access to a ton of games and lets you program in it, then you'll be able to like go in and edit the code and run the code on your own Pico 8, which is one of the really cool things about that system and why I'm becoming obsessed with it, is that it's like automatically open source. And if you play a game and you're curious how they did something, you push escape and you go look in the editor and see how they did it, which is really cool. Other questions? Maybe not. Okay. Tyler, Jacob, do you want to stick around or? Okay. Oh, cool. There we go. Michael has a question. What elements in a game are the most important to add particles to? Okay, yeah, that's a good question. So like one of the things that visual effects does very well, it's sort of like a running joke within the industry, is like if somebody is, let's say you're making a character that can turn into like a werewolf, and they're a human and then they're a werewolf, making all of the animations to do that properly, to go through all the steps there, is going to take a lot of work and effort. And so it's much more common to just be like, it's a human, poof, particles. Now it's a werewolf. And so like one of the things that you can do with effects is like cover up transitions. You see that a lot with like if a door is blown up or if a building is falling over, all of the messy transitions from like one version of the game world into a different version of the game world is always going to be covered up with a ton of particles that are really opaque, to make it so that like you get to save all of the other artists a ton of time. But yeah, so like that's one of the tricks that you can do with them. But more generally, like what particles do is they add a lot of sort of life and unpredictability to things. They add motion, they add a lot of dynamism, and so so in general, I would say like you want to be adding them to things that that should have motion, but that motion is difficult to precisely model or precisely like animate. And so like you wouldn't do it to like particles are not really good for showing like how a character moves through space. We have good mathematical representations for that and good like modeling representations for that. But fire isn't something that you would want somebody painstakingly crafting. Like how do the tongues of the flame move? And so it's like you want motion and you want randomness. That's where you put particles. The other thing I would say is just like if a section of the game needs effects and needs particles and doesn't have them, it can feel pretty obvious. It feels just kind of dead, particularly like once you start putting effects in some of the game. Then when you enter an area that doesn't have it, which is totally part of the process, like some part of the game will be done before the others. Like it, your brain notices, like, oh wow, this area feels completely dead. And so it's something that like once you've got some of them in place, it becomes more clear where else you need to put them. Other questions? And like while I'm talking, you can feel free to drop more questions in the chat if you have them. So. Okay. It's feeling like we're probably not going to get anywhere. Are Jacob or Tyler there? I don't know whether I need to do anything else in order to sort of wrap this stream up. Cool. Thanks, Manib. Yeah. Yeah, this is fun. I definitely enjoy giving these talks. I'm not sure what I'll talk about next time because those are the two subjects that I felt ready. Ah, there you are. Hey. So, yeah, I think so.
Law. 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 Law.